So we're going to finish our solving literal equations with two problems that have applications to geometry. So let's read through the first problem. What is the height of a triangle that has an area of 24 square inches and a base of length 8 inches? So we've got two pieces of given information. First of all, we have an area that's 24 square inches, and the base of the triangle is 8 inches. So bullet point number 1 here says, let's draw a diagram to represent the given information. So remember, area is how much space and a figure is going to cover. So perimeter is the sum of the sides, and area is the surface that it's covering. That's why it's measured in square inches, which is a two-dimensional measurement. And you can draw any triangle that you like here, and we're going to let the base be 8 and the area is 24. So that's a diagram representing the given information. And now I've got use substitution and solve the equation. Well, we got to use substitution. We've got to put this information into the formula for the area of a triangle, which area of a triangle equals 1/2 the base times the height. So we know that A is 24, so I'm going to use substitution here and plug it in. Equals 1/2 times the base. We're given that the base is 8, and then times the height. Now, the height of the triangle is this particular distance. It's the actual height, not a slant height. That's what those two sides would be considered, but the actual height, and that height is perpendicular to that bottom base. So here's our equation. So now we're going to use inverse operations, and remember, inverse operations are what help us transform equations. So first thing we need to do is follow order of operations and simplify this right-hand side of the equation. 1/2 of 8 is 4. So 24 equals 4 times h. And then from there, to undo multiplication, we're going to divide. Division is the inverse operation of multiplication. I'll move to the right here. So h equals 6. And h represents the height of the triangle. So we solve the equation. We answered the question. The question says, what is the height? That was our unknown. So that's our first question. Here's our second one. So just like we've said in previous videos, whenever you've got a lengthy word problem, be sure to read it all the way through first, and then we'll go back and mark all the given and useful information. The formula for the volume of a cylinder is V equals pi r squared times h, where r is the radius of the circular base and h is the height of the cylinder. First question, first part of the question. Solve for r by transforming the formula. So we've got to transform this formula and solve for r. Secondly, if the volume is 1,884 cubic centimeters, when the height is 6 centimeters, find the length of the radius in centimeters. Okay, so let's go back. Let's highlight, and that's where your highlighter's handy. Let's highlight everything that's useful here. The volume of a cylinder is this formula. V equals pi r squared, hopefully that looks familiar, times h. So r is the radius, circular base, h is the height, cylinder. Number 1, we've got two things to do here. Solve for r by transforming the formula. And then, of course, we're told that V equals 1,884. and H is 6. Find the length. Find the length of the radius. So R is going to be what we're solving for here. So let's follow our instructions here. Draw a diagram to represent the given information. So this is a cylinder, and a cylinder is just like a Coke can or a can of soup. So here is our cylinder. Here's my handy picture. And here's what we know. We are given that the volume, and a volume is the capacity of this cylinder. It's how much it can hold in cubic centimeters. So volume, 1,884 cubic centimeters. The height. So the height is this side of the cylinder. The height is 6 centimeters. So let's write down our formula. V equals pi r squared times h. And I'm going to take down the parentheses there because we need to be taking a look and asking the question, what's been done to the r? The r has been squared, so we're going to have to use an inverse operation for squaring. It's been multiplied by pi. We're going to have to undo multiplication. It's also been multiplied by h. So what are we solving for? We're solving for r. So we've got to take away the pi, we've got to take away the h. Remember, when we're solving, we need to go in reverse order of operations. So if we're going in reverse, we would try to undo the subtraction or addition first. There is not any subtraction or addition, so we go to the multiplication. Let's undo the multiplication. And it doesn't matter the value for pi at this time. It doesn't matter the value for h at this time. The first part says solve for r by transforming the formula, so that's what we're going to do. So to undo times pi and times h, the inverse operation is division. And we don't need to do it in 2 steps, we can do it in 1. So pi divided by pi is 1, h divided by h is 1. So that leaves r squared equals v over pi times h. So now we're going to be undoing a square. So let's take a look at my calculator for just a minute. And these calculators are set up in a way that's pretty logical. I'm going to zoom in down right on the keypad. And what I want to point out is here's the squaring key. And the second function of the squaring key is the square root. So the square and the square root are inverse operations of each other. And here's another one that you'll be very familiar with. The on button. What's the second function of the on button? Off. Why? Because they're inverse operations of each other. One undoes the other. Just like the square and the square root. So lots of other keys behave that way on the calculator as well, and you'll learn about those more in later math classes. So back to our problem. In our problem, we need to undo r squared. And in order to undo that r squared, we have to take the square root of each side. So the square root of r squared is r. For the same reason on my calculator, if I say 5 squared and I get 25, and then I take the square root of 25, I get 5, right back where I started. They are inverse operations. Now the good news is there's nothing I need to do other than just write that handsome radical. So there's the answer to number 1. We have transformed the formula and solved for r. Now, let's use that and let's finish number 2. Number 2 says the volume is 1,884. So I'm going to use this formula and I'm going to plug in V equals 1,884 over pi, now is the time to use your 3.14 for pi, times h, which is 6, that is equal to r. So now is a good time for your calculator, whatever calculator you've got. We're going to follow order of operations. Remember that the radical sign is a grouping symbol, so we need to do everything inside of it first. So inside of there, we've got 1884 over 3.14 times 6. 3.14 times 6 is 18.84. Amazing. And then we're going to do the division. 1884 divided by 18.84 is exactly 100. And I hope that somebody out there is excited and can tell me that the square root of 100 is 10. R is 10. So we have answered both of the questions here. We've solved for r by transforming the formula, and we have found the length of the radius in centimeters. Our radius is 10 centimeters.